Alright, in this video we're going to be looking at how to find the least common multiple of a set of numbers or some polynomial expressions. And why we might want to do that is if we're running into maybe an equation we're wanting to solve and we want to get rid of the fractions, we'd multiply by the least common multiple, or fraction busting. Maybe we want to add two fractions, so we need the least common multiple or the least common denominator. So we're finding the, I'll speed this up, finding the LCM, or least common multiple. And the least common multiple is the smallest positive multiple of a set of numbers. And maybe we'll say not just a set of numbers, how about a set of integers? Okay, so the least common multiple is the smallest positive multiple of a set of integers. So let's do an example. Find the LCM of 6 and 8. I'm going to tell you that it's 24. Now, one way we can get that the least common multiple is 24 is we can list multiples of 8 and 6. One common method that you might have done is you just multiplied 8 and 6 and you got 48. 48 works for whatever we wanted to do with it, but it's not ideal because it's a larger number. Larger numbers, you might be more inclined to make a mistake. So we're going to try to keep our numbers a little bit smaller. So if we list some multiples of 8, 16, 24, 32, 40, etc. Multiples of 6, 6, 12, 18, 24, 30, 36, 42, etc. Okay? And we're looking for the least, or the smallest of these multiples, and it happens to be 24. And then I'm going to go ahead and do the prime factorization of both the 8 and the 6. And this is probably the quickest method. After you get pretty experienced with it, you can kind of just look at 8 and 6, and you know, if the numbers are pretty small, a lot of times it's fairly easy to just do it in your head. But if you want a more systematic way of doing that, you would find the prime factorization. And when you start dealing with algebraic expressions, you might want to be dealing with prime factorizations. Well, sort of prime factorizations with the polynomial expressions. Okay, so if I do prime factorization of 8 and prime factorization of 6. So 8 is 3 2's and 6 is a 2 and a 3. So what we're going to do is we're going to take one of each prime number. So I see a prime number of 2 and a prime number of 3. And then I'm going to take the highest or the most I see in any specific prime factorization. So I see 2 appears 3 times in 8 and only once in 6. So we're going to take the most times I see it in a specific prime factorization. So I'm going to have a 2 to the third. And then I only see 3 appears in 6, and it's only once, so we just take 3 to the first. Okay. Okay. And here's what they look like as prime factorizations. 8 is 2 cubed, 6 is 2 times 3. So the LCM is 2 cubed times 3, which is 24. Okay, and we got the same answer 3 different ways, and the prime factorization way is kind of probably going to be the best when we start dealing with polynomial expressions or even larger numbers. It's probably the best than listing common multiples or doing some guess and check. So again, I look at the prime factors. So I see a prime factor of 2 and a prime factor of 3. So I'm going to include a prime factor of 2 and a prime factor of 3. And then we'll take the highest exponent I see. Highest exponent of 2 I see is 3. Highest exponent of 3 I see is just the first power. Alright, so let's move on to that next slide and we'll do another example. So let's find the LCM of 8 and 36. So I'll go ahead and list out some multiples of 8. You can check on your, if you want to pause the video and check, you can check that these are in fact multiples. Okay. All right. Now you see the issue here is it took us a little bit longer with multiples of 8. We had to go all the way out to 72 before I got common multiple here. And it's the smallest one. And so the LCM here is 72. Okay, so we said this takes a while. So we're trying to save you some time. And another common method that we use is we just multiply the two numbers. So 8 times 36 is 288, and that's a little bit larger than we probably want to deal with. Big numbers can kind of be scary or something, so we'll try to keep it smaller. I rather would deal with 72 than 288, and I like numbers, so I would go with the 72. Okay. All right. So if we look at the prime factorizations again, I'm going to go ahead and just tell you that prime factorization of 36 is 2 squared times 3 squared. That's 4 times 9. And we're going to take one of each prime. So we're going to take a prime of 2, and we're going to take a prime of 3. And then I'm going to take the highest power. I don't count how many it appears altogether. I see 2 appears 5 times, 3 in the 8, 2 in the 36. I'm not going to do that. I'm just going to pick the highest. I see it appear 3 times in the 8, and I see it appear twice in the 36. So multiplying those together, that's going to be 8 times 9, that's 72. And that's good. So matches up those two ways. Okay. All right. So let's do a little bit more fun problems. So let's find the LCM of a set of numbers. Well, that's what we just did, wasn't it? To find the LCM of a set of numbers. Find the prime factorization of each number. Take one of each prime. Take the highest exponent of each prime. And then their product is the LCM. So if you want kind of a, maybe write this down as you're working on some problems where you might be required to, I call them fraction busting. You may call it something different in your class, but if I'm looking for least common multiple of some numbers, this is what I would want to do. I might write this down to kind of refer to and then practice it, and then once you get the hang of it, you don't even have to read this. You kind of just have the muscle memory to go ahead and do that. Okay, now let's add another level to this and make this a little bit more fun. We'll find the LCM of an algebraic expression. So we'll give you some rules here. So same as the LCM of integers, and then the highest exponent of each variable. So we'll do an example in just a minute, but this is kind of maybe your guideline for doing that also. So you find the LCM of the integers, and then you're going to take one of each exponent. So maybe you got like an x and a y and a z, and then you'll just take the highest exponent of each one of those you see. Okay, so example, we'll look at the LCM of, let's see how many we want to put in here. So we got all kinds of goodies here. So we're going to find the LCM of 32 x squared y to the 7th z and negative 18 x y to the 10th z squared. The negative doesn't matter. We want the smallest positive. There's no smallest negative, unfortunately. Well, probably good there isn't one. So if we did the prime factorization, 32 is 2 to the 5th, and 18 is 2 times 9, or 2 times 3 squared. So we're going to take one of each prime. So we're going to take a prime of 2 and a prime of 3. Highest exponent of 2 is to the 5th, so we'll have a 2 to the 5th, and there's a 3 squared. There's no other 3, so we just take the 3 squared. Okay. And then we just go and we pick out the highest powers of the x and y and z. Highest power of x is this x squared. Highest power of y is the y to the 10th. Highest power of z is z squared. And I went ahead and multiply all that junk together, and we got 288, which is what we were looking at the last time, just coincidence. 288 x squared y 10 z squared. So if we were working on some problem where I wanted to find the least common multiple, for whatever reason, this is kind of the probably the best method of doing that. Okay. And what about finding the LCM of polynomials? Okay. So I'll read this in just a second as it's written. So it's kind of the same as before, and so I think I meant to write now, not. So let's try this again. So it's same as before, but now you need to factor the polynomial. So if you haven't watched one of the polynomial videos, or factoring polynomials, the greatest common factor, perfect square trinomials, the difference of squares, you might want to watch that, or with the AC method. If you're comfortable with factoring, then you should be able to follow along just fine. So let's keep going with this one. So let's find the LCM of 3x squared minus 75 and x plus 5. Okay, so what I would like to do first is to factor it. So we can factor a polynomial over the complex numbers into irreducibles, but a lot of times we're going to take things that are fairly nice. And we actually factored this one in the other video, 3x squared minus 75. Greatest common factor is a 3, and then we have 3 times x squared minus 25. X squared minus 25 is a difference of squares, so it'll be x minus 5, x plus 5. Okay. Now you see that 3 out in front there. We'd find the LCM of 3, and then if we had any other numbers, we'd play the same game. And then we'd play a similar game with our factors now. Let me write the other one in just a second. So I mentioned that x minus 5 and x plus 5, these are irreducible. So this is kind of like primes for like a polynomial. Okay. And so I was looking at what's the LCM of 3x squared minus 75. So we went ahead and factored that. It was 3x minus 5, x plus 5. Our other one was x plus 5. And that's already irreducible. So it's kind of like it's already a prime. Okay. So here's what I say our LCM is. I see the number 3, so we're going to go ahead and include the number 3. Then I'm going to take one of the polynomial irreducibles, one of each factor. So 3 is a factor, the x minus 5 is a factor, and the x plus 5 is a factor. So I'm going to take one of each factor and then the highest power. Well, everything's to the first power. There you have it. That's your LCM.